Hey guys, in this video we're going to make metallic tin crystals from stannous chloride. Let's get to it. So this is what you'll need to carry out this experiment. You'll need stannous chloride, a beaker, some warm water, a 9-volt battery, alligator clips, and paper clips. Each of the paper clips will serve as an electrode and are clamped to each side of the beaker. In a separate beaker, I'll dissolve a little bit of stannous chloride in some warm water. I'll then stir it up until every last crystal is dissolved. The other cup is then filled with the stannous chloride solution. I've added about 40 milliliters of the solution to it. Then, to the power source, an alligator clip is attached to the positive and negative terminals. The moment the circuit is completed by connecting the second alligator clip, the crystals should start to grow. The crystals will grow from whichever alligator clip was attached to the negative terminal. So after it was attached, we can see the crystals starting to grow. Initially, it was nice to see the crystals starting to grow, but it was disappointing because it was quite slow and only a few crystals were growing. I was honestly quite shocked that the crystals were growing from both sides of the alligator clips, even though that they should have only have grown from the negative terminal. I was very underwhelmed with the result, so I decided that I'm going to need something with more current if I want more crystals to grow. The crystals are small and fragile, but it is possible to collect them if you like. So after a while of searching around, I did find an old power source from a laptop charger that I had laying around. I cut the end off and stripped away about an inch off of the end. The free copper wire that you see wrapped around the inner white wire is generally the negative or the ground. So it was removed from the white wire and twisted up a bit. Then with the white wire free, it was stripped to expose the inner wire, which is the positive. So these will be our positive and negative terminals instead of the battery. Then, just like before, we attach an alligator clip to each of the terminals. Generally, the wrap wire is positive, but depending on the polarity of your adapter, it could be negative. Then, to get things going, we plug it in and see what happens. Just like before, I poured in the solution into the beaker, but this time I placed the paper clips closer to one another to further increase the speed of the crystal's growth. We can see that the crystals are growing faster than before because of the more powerful power supply. However, due to the stronger power input, it starts to heat up the solution, and you can see that it starts to boil a little. So what's basically happening here is known as a redox reaction. What's happening is that the tin ions are being oxidized at one end and reduced at another. So the stannous chloride starts off as tin 2+, but at one side receives electrons and another it gives away electrons. At the positive side, tin 2+ is giving away 2 electrons to form tin 4+, and at the negative side is receiving 2 electrons to form tin 0 or tin metal. As I kept the power running, the crystals grew larger and larger until it started smoking and caught on fire. I think this was caused by the close proximity of the two alligator clips. It is possible to filter out the tin crystals, which I tried, but was left with a bunch of goo. It was gray and dark as opposed to shiny crystals. I think the tin was impure or that there was some possible contaminants. I did later manage to scoop up a bit of the dark substance and clump it into a tiny ball of tin. It was really interesting to me that in all of my previous attempts, the crystals were growing from both sides of the clips, and in the last one, it only grew from the negative terminal. Thank you so much for watching this video. If you have any other video ideas, please leave them down in the comments below. And as always, thank you for watching.